what you're going to find for the rest of this unit is that we are going to study specifically four-sided figures, so quadrilaterals. So what we're going to do for the next several lessons is look at in different types of quadrilaterals and the different properties that they have. So the first one we're going to start with is the most basic one, which is a parallelogram. So a parallelogram, by definition, is a four-sided figure with opposite sides that are parallel to each other. So in other words, if you're looking at this first picture that I have up here, the top side and the bottom side are parallel to each other. Remember from our two parallel lines and a transversal unit, when we see arrows on lines like I put up there in purple, that means that those sides are parallel to each other, not congruent to each other. The left side and the right side are also the exact same. They would be parallel to each other. So opposite sides parallel make a parallelogram. Now what we learn with a parallelogram is that we have a definition that the opposite sides are parallel, and what that does is it feeds into several different properties that also end up being true. One of those properties being that the opposite sides are congruent to each other. So in my first picture on the top left, my top side QR and my bottom side PS are a pair of congruent sides. My left side QP and my right side RS are also a pair of congruent sides. What we also learn is that the opposite angles are congruent. So in my picture on the right hand side, angle Q and angle S would have the exact same degree measure. And likewise, angle P and angle R would have the exact same angle measure. So what we're going to do in the couple of problems below is use those properties in order to solve for the variables. So in the first problem here on the left, to solve for x, angle B and angle D are opposite angles in a parallelogram, which means from the property above, they are congruent to each other. So if I take 2x and set it equal to 22, I can easily solve for x by dividing by 2. You get 61. If I want to figure out the value of y is a side length, and so is 7. They're opposite sides in a parallelogram, which means they have to be congruent, so y is just simply 7. In the next problem, angle C and angle A are opposite angles in a parallelogram. They're across the parallelogram from each other, which means, again, they are congruent, just like in the last problem. So I can go ahead and set them equal, and then I'm just going to solve the equation for x. So I'm going to do two things. Subtracting 9x gives me 3x. Adding 34 gives me 36. And solving for x by dividing gives me x equals 12. In the last problem, very similar strategies that we've been doing in the last two problems. If I want to solve for A is a side length, A minus 10. The opposite side across the parallelogram has to be congruent to A minus 10. So A minus 10 has to be equal to 18. And solving very simply by adding 10, we get A equals 28. To solve for B plus 16 and 103 are opposite angles in a parallelogram. According to the property above, that means they are congruent. So we're just going to set B plus 16 equal to 103. And all I need to do is subtract. So subtracting 16 from 103 gives me a B value in this case of 87. So the algebra portion of this really isn't all that difficult. The difficult part is going to be remembering the properties and what do you do with the properties, because not all the properties are the same. So moving down, there are a couple of more. The next one is that we learn that consecutive angles are supplementary in a parallelogram. So what do I mean by consecutive? The ones, two in a row. So the two that I circled in purple, those would add up to be 180 degrees. They're supplementary. The two on the top, X and Y, again, two in a row. The ones I circled in blue would add up to be 180. The Y and the X, the two that I just circled, would add up to be 180. The X and the Y, the two I just circled, would add up to be 180. So it doesn't matter which consecutive ones you use, they always are supplementary. The last property we're going to talk about is the fact that the diagonals in a parallelogram bisect each other. So I have a diagonal QS and I have a diagonal PR. The blue and the purple split each other into two equal parts. So from P to M and R to M are congruent, and from Q to M and S to M are congruent. So the diagonals are not congruent to each other, but they do bisect each other. So they split each other into congruent parts. Coming down, 3 problems dealing with those 2 properties. So in the first one, we've got diagonals. So what we know is that the pieces of the diagonals are congruent to each other. So the 2 purple. So 9 minus n equals 2n. To solve, I would add n to both sides. So 9 equals 3n. And dividing by 3 gives me n equals 3. The other diagonal is also bisected, so the 2 blue portions are congruent. So 16 equals 4m. And if I divide, we get that m is 4. In the next problem, there are a couple of ways we can go about doing this. I obviously cannot set the opposite angles congruent because one has an x and one has a y. So using the property that we had used previously isn't going to work for this problem. So what we do is realize that we've got consecutive angles here, and what I know from above is that they are supplementary. So x plus 70 should equal 180 when you add them together. Subtracting 70 gives me a value of 110. We can do a couple of different things to solve for y. I know that this is 110 now. So now I can set the opposite angles congruent and solve for y. So easily done. If I subtract 10, we end up with a value of 100. Again, the algebra portion of this isn't going to be overly difficult. It's just remembering what property you're supposed to be using for the problem. In the next one, similar to the first one we did, we've got diagonals bisecting each other. So those 2 yellowish ones, those pieces are equal, so 3x equals 12. And if you divide, we end up with x equals 4. The other set of diagonal pieces are congruent also, so 5y and 4y plus 4. Simply by subtracting 4y, we end up with y equals 4. So again, the algebra, not overly difficult. Last problem on the bottom, same picture for all 4 parts. So let's talk about some things we can do. Angle EDG. EDG is this angle here. And so what we notice is this angle down here is 50 degrees. And so EDG is its opposite angle. They have to be congruent because this is a parallelogram. If I want to figure out what EH is that purple piece there. It's a portion of the diagonal. The other portion in purple here is 8, which means that EH must also be 8. If I want to find the value of y, y is part of a side length, so its opposite side must be the exact same. So 6y minus 9 must equal 21 because opposite sides in a parallelogram are congruent. Adding 9 gives me 6y equals 30. And dividing by 6 gives me y equals 5. The last thing we're going to do in the problem is solve for x. X is this angle down here at G. And I've got this angle here also, which is 50. We know consecutive angles, so 2 in a row, are supplementary. So 7x plus 4 and 50 have to equal 180 because they're consecutive angles in a parallelogram. They are supplementary, not congruent. So putting 50 and 4 together gives you 54. If I subtract 54 from both sides, I get 126. And the last thing I would need to do is divide 126 by 7. We end up with an x value of 18. So again, the hard part of this is figuring out which property is appropriate and then remembering what the property says. Now, turning to the back side, we are going to talk about the properties very, very similarly. We're just going to look at them in a different direction. So on all of the problems on the front, you were told to begin with that the figure was a parallelogram, and then you were told that all of these properties follow with knowing that you have a parallelogram. On the back, we're looking at ways to show that a figure is a parallelogram. So when you start a problem, you don't necessarily know if it's a parallelogram, and what we learn is there are 5 ways that you can tell me that a figure is a parallelogram. Number 1 being by its definition. If you can show that the opposite sides are parallel to each other, then the figure is a parallelogram. If you can show the opposite sides are congruent to each other, then the figure is a parallelogram. If you can show the opposite angles are congruent, then the figure is a parallelogram. If you can show that you have one pair of sides that's both congruent and parallel, notice the picture, the same pair of sides is congruent and parallel, the top and the bottom, then that figure is a parallelogram. If you can show that the diagonals bisect each other on the inside, then that figure is a parallelogram. So what we're going to do in this set of problems here is we're going to look at the figure and determine, can I say this is a parallelogram? Yes or no? And we're going to tell why. So what we're looking at here is a 4-sided figure, and we've got 3 of the angles already. What we have to do is figure out what's this 4th angle. So this is a quadrilateral, and so what we know is that all the angles in a quadrilateral add up to 360. That's something you can do using the n-2 times 180 if you don't know that off the top of your head. And so if we subtract off the angles that we already know, we can figure out what the last angle is. So if we subtract off all of those, what you'll find is this last angle is no longer a question mark. It's actually 75 degrees. So if we're looking at these angles, notice that the opposite angles are congruent to each other. So I've got 75 and 75, and I've got 105 and 105. So yes, this is a parallelogram, and the reason why is because opposite angles are congruent. So it's kind of like a little mini proof, but not really, because you're not having to write a bunch of statements and reasons. All we're doing is using number values in the problem and then saying, yes, it's a parallelogram because of this reason. The opposite angles are congruent. So it's almost like a mini proof that you're doing in your head. In the next one, notice that the left side and right side are the exact same. Notice the top and the bottom are the exact same. From above, we have a property that says, yes, this is a parallelogram, and the reason why, opposite sides are congruent. That's one of my 5 reasons. In the next one, notice that you've got 2 diagonals. The purple one, each piece is 3.6. The blue one, each piece is 5, which means that they bisect each other. So yes, this is a parallelogram, because the diagonals bisect each other. In the next one, all you're told is that you have 4 right angles. So noticing angle A and angle C are opposite and congruent. Angle D and angle B are opposite and congruent. So I have opposite angles congruent, which means that yes, this is a parallelogram. In the last one here on the right-hand side, the first thing that we should notice is that we've got one pair of sides that's marked parallel and congruent. So from above, we have a property that says if one pair of sides is marked parallel and congruent, then this is a parallelogram. So yes, this is a parallelogram. one pair of sides, both parallel and congruent. So all you're looking at a figure, all you're doing is for this problem is looking at the figure and telling, does it fit one of the properties that's listed above? Moving down, we are going to show what values would be necessary in order to make these parallelograms. So we're using generally the same exact properties that we used on the pictures on the front hand side of your sheet. So these two pieces are both portions of a diagonal, and we know that in order for this to be a parallelogram, those two pieces have to be equal. So we're going to set them equal and find the value of x that makes that true. So a couple of things, we would subtract x to get 2x. We would also add 11 to get 16. And dividing gives me an x value of 8. In the next problem, the two angles that are marked are consecutive angles in a parallelogram. From the front side and from above, we know that in order for this to be a parallelogram, those two angles aren't going to be equal to each other. Those two angles have to be supplementary to each other. And the reason why is because they are consecutive angles in a parallelogram, not opposite angles in a parallelogram. So doing some rearranging here, we've got 6x's and a minus 6. If we add 6 to both sides, we get 186. And if I divide by 6, I get 31. Last part of this is these two angles here. So these two angles, notice the ones that they're pointing to. Those are opposite angles in a parallelogram. In order to be a parallelogram, those opposite angles have to be congruent to each other. That's the property. If they aren't congruent to each other, then it's not a parallelogram. So the problem is asking you to find x so that the figure is a parallelogram, which means that that property has to be true. So a couple of things here. Let's subtract x to get 2x. Let's add 13, we'll get 32. And if we divide, we get 16. All right, one last problem. This says, show that A, B, C, D are the vertices of a parallelogram. So the first thing I should do with this is actually graph the parallelogram. So 1, 3 gives me an A dot there. 3, 5 gives me B there. 9, 1 would be over here. And 7, negative 1 would be down here. So what are we supposed to do? There are a couple of ways that we can show that something is a parallelogram. One of the ways is to use the distance formula and figure out that the opposite sides are congruent to each other. Now, distance formula is a longer process, so that's not really the one I'm going to choose to do. So from above, if you look at your 5 things that can show you have a parallelogram, one of them is by showing the opposite sides are parallel to each other. That's a whole lot easier to do in math because all we have to do is find the slopes of the sides. So from a graph, all I have to do is count. So that's a whole lot easier than doing the distance formula. So let's talk about which sides have to have the same slopes. AB and CD are opposite sides. They would have to have the same slope to show that they're parallel. Same thing is true with BC and AD. They're opposite sides, so they would have to have the same slope in order to be parallel to each other. So all we're going to do is count on the graph and figure out what the slopes are. So let's start with AB. To go from A to B, we're going to go up 2 and over 2. So 2 over 2 is a slope of 1. Same thing for CD. We are going to go up 2 and over 2. 2 over 2 is a slope of 1, which means that those opposite sides are in fact parallel because their slopes are the same. Let's do the same thing for AD and BC. To go from B to C, we have to go down 1, 2, 3, 4, and we have to go to the right 1, 2, 3, 4, 5, 6. So negative 4 over 6 is a slope of negative 2/3, which means that in order for AD to be parallel to BC, it has to have that same slope. So all we're going to do is count. We have to go down 1, 2, 3, 4, and we have to go to the right 6 spaces. So again, I get a slope of negative 4 over 6, which reduces to negative 2/3. So are the opposite sides parallel to each other? These two are parallel because they have the same slope. These two are parallel because they have the same slope. So yes, this is a parallelogram. And the reason why, opposite sides are parallel. So not only do we have to do the math work, but we also have to explain or provide the explanation on what the math work tells you. Since the slopes are the same for the opposite sides, that means the opposite sides are parallel. That means that it is a parallelogram. Make note of any questions that you have. I would imagine that some of you may have a lot of questions about this last problem. And if we need to go over another one or another couple like that, then that is fine. Just make notes so that you can ask about them in class.